Good morning. It's actually morning for me. It is about 6 a.m. today, and here I am doing stats with you, which is awesome. This is actually a nice little lesson today. I'm going to be pretty quick, and also your homework will be really quick. Then you'll have a nice 3-day weekend, which will be fun. Hey, good job for watching the video. You're doing a great job. Hopefully this week hasn't been too rough on you and your other classes. I miss you guys a whole bunch. Miss talking to you a lot, especially. More than my Algebra 1 classes, I just miss being with you guys. So, didn't realize I was going to get gross this morning and emotional, so sorry, I'll quit that immediately. Penny story. Oh, okay, so I recorded a video last night for my algebra classes, and in the early evening, and Penny wanted to be part of it. She literally just said, sorry, yawning. She said, did I make you yawn with my yawning noises? Maybe. She just said hi on the video, and then said that she wanted to be on YouTube because she is, really into YouTube, like a lot of little kids are, especially watching like gaming videos and stuff like that, and animation videos. And so she said that if she said hi on this, I mean, like not even her face, just her voice, that if she said hi, that would be the start of maybe her becoming a YouTube star someday. So I guess I gave her start today as a YouTube star. Everybody knows that these videos are super famous, so that'll help her out her career, I think. Yeah. I'll have to make sure that she says hi, or maybe even Zandy says hi in one of these videos here, if I can handle Zandy and then whisk him away and still teach. Okay, let's get down to some 6.3 notes. You should have printed them off. Probably should have written that on the list too. I'm kind of assuming that you know it at this point, but if I'm going to make a to-do list, I might as well make an actual complete to-do list. Okay, let me make this big. So we're going to get right down into the T-chart today. Hope you guys still like doing T-charts, because I'm going to keep doing them unless you tell me that you don't like them. Okay. So, the first thing you need to do when you're making a proportion confidence interval. So the first section was about how to make a confidence interval for a mean, if you know the standard deviation for the population. The second one, 6.2, was how to make a confidence interval for a mean, if you do not know the population standard deviation. Oh, I love coffee. Okay. The third section is how to make a confidence interval for a proportion. So, the first step is to find x, n, p hat, and q hat. I don't think, when we did binomial distributions, we had p and q, but I don't think we had p hat and q hat. They just look like a little p with kind of a what do you call those? I forget the word. That sign, caret, the caret over it. Just like you would use if you were going to do a power on your calculator. And it is literally called p hat, like this. Yeah, like the word fat, which is hilarious for me. Anyway, so p hat and q hat. I'm sure that if I were with you right now, you'd be coming up with things that you have to call it from now on, like fat, to embarrass your college professors someday. So, or at least embarrass me in front of them. So, x is your number of successes. P hat is x over n, and q hat is so this is the probability of success, and q hat's the probability of failure, so you just subtract the probability of success, just like a binomial distribution. Number 2, you have to verify that this can be done. Just like in binomials, we have to take p hat times n and make sure that's bigger than 5, and q hat times n and make sure that's bigger than 5. You don't have to check both of them, or it could be equal to 5. You don't have to check both of them, just check the smaller one, because if the smaller one works, the larger one definitely works. Next up, you have to find z sub c, so we're going back to page A16, A17, the z chart in your notebook. Then you find the margin of error. This formula is E equals z sub c times big square root of p hat times q hat, all divided by n. Okay, 5 is to make the confidence interval. And that is like this. So p hat goes in the middle this time. Over here we're adding the error, and over here we're subtracting the error. And then you have to put it in context by writing a sentence, because that is what you always do with AP questions specifically. Okay, so let's move on to example 1. I'm going to do this according to my directions here. So instead of sliding back and forth, you can look up at your own directions, I'm sure. Okay, so for number 1, I was supposed to find x, which is right here. It says, in a survey of 1,000 teenagers, 672 said that they own smartphones. Construct a 95% confidence interval for the population proportion of the U.S. teens who own smartphones. Okay. By the way, this kind of confidence interval is used a lot. You'll see it with political polling. You'll see it lots of places in the news or in the media when they're trying to get information. They'll usually give you a range of percentages where something might be true, and that's where this all comes from. So 672 divided by 1,000, that's pretty easy math. Don't even need my calculator. That's 0.672 and 0.328. Okay, for number 2, you have to verify that this can be done, which means you take n times p hat and n times q hat and see if they're bigger than or equal to 5. I'm not going to do that because I know that 32.8%, whoa, guys, I think I just saw a mosquito in my house. No, it's a fly. Still a fly in my house. Weird, it's April. It's like the nicest day yesterday, which is definitely Mother Nature's trick, saying that, oh, can you not go outside and enjoy this? Here, it's beautiful, instead of the normal snowstorm we give you. Okay, sorry, I got distracted by literally a fly. Okay, so Q hat is 32.8%. I know that 32.8% of 1,000 is bigger than 5. So I'm just going to put a check there. I'm not even going to write it down, even though I could say that it was 328, but I'm not going to write it down because it's not worth my time. All right, Z sub C. Just a little refresher for those of you who don't remember how to do Z sub C. So you've got a beautiful bell. Look at that edge there. Beautiful. I'm not going to change it. Bell curve. It says 95% is in the middle. So on the edges here, this would be 2.5% here and 2.5% here. If you look it up on A16, A17, you have to look up 2.5% in the middle of the chart because that's where all the percentages are. That gives a value of negative 1.96 for a z-score here and a positive 1.96 for a z-score there. We're going to use the positive one for our math. So for number 4, the margin of error is z sub c, which is 1.96 times the square root of 0.672, which is p hat, times 0.328, which is q hat, all divided by 1,000. And if you do that math, you get 0.029. Alright, number 5, confidence interval, TIE fighter. It's so weird making these jokes, wondering if any of you find any of this funny. Probably not. I'm just going to have to keep going. Just going to have to keep making it work. Tell jokes without people laughing, which is my normal life.